We are going to make some more examples about theoretical probability. Let's go to example 7 in our book. So, a dice has the numbers 0, 0, 1, 1, 4 and 5, and it rolled twice. So you have to illustrate the possible outcomes using a two-dimensional grid. Okay, so we have two axes, the vertical one and the horizontal one. The horizontal one is for roll 1, the first time you rolled, and the vertical one is for the second time you rolled. And the possible answers are 0, 0, 1, 1, 4, 5. So 0, 0, 1, 1, 4, and 5. And the same for the second roll. The possible outcomes are 0, 0, 1, 1, 4, and 5. Okay. I draw the vertical lines. And the horizontal ones. We've learned in part C how to draw a two-dimensional grid. So those are the possible outcomes. The blue point that I'm drawing now. Okay, and this is the answer to A. Let's go to B. And there you have to find the probability of getting a total of 5 for I, and for II two numbers which are the same. So let's focus for the first one first, to the first one. So, but before we do that, let's find the outcomes in the sample space, the number of outcomes in the sample space. Of outcomes in the sample space. For the first roll we have 6 possible outcomes. For the second roll we have 6 possible outcomes. So the number of outcomes in the sample space will become 6 times 6, which is 36. So we have in total 36 possible outcomes in the sample space. Okay. And for I we have to find the probability of getting a total of 5. A total of 5. So what does that mean? The number that you got from in the first roll plus the number that you got in the second roll must be equal to 5. So for example, this one is okay because in the first roll you threw a 5 and a 0 on the second one. 0 plus 5 is 5. This one is also okay because first roll 5, second roll 0. This one is not okay because the first roll is a 4, the second roll is a 0. So that's not okay. But this one here is okay because like the first roll is a 4 and the second roll is a 1. 4 plus 1 is 5. This one is also okay. And then here first roll 1, second roll 4, and here as well. And then here first roll 0, second roll 5, and here as well. So what do we see? To find the probability of getting a total of 5, we have to do the number of outcomes that we just counted here, 1, 2, 3, 4, 5, 6, 7, 8, this 8 here, divided by the number of outcomes in the sample space, which is 36. So this 8 we got by counting in the two-dimensional grid. And we can simplify that, that is equal to 2 over 9. And for the second one, we have to find the probability of getting two numbers which are the same. So the probability of, let's say, same numbers. Okay, let's count them on the two-dimensional grid. So here, the first dice roll is a 5, the second roll is a 5, so that is the same. This one is not the same because here the first roll is a 5, the second one is a 4. But this one is the same. The first roll is a 4, the second roll is a 4. This one is the same. The first roll is a 1, the second one is a 1. This one as well, this one as well, and this one as well. And then here the first one is a 0, the second one is a 0, here as well, and here as well. So if we count this, we have in total 4, 4, 2, 10 possible outcomes. So it's a 10. And we divide that by the number of outcomes in the sample space, which is 36. So that becomes a 5 over 18. Okay? Let's go to another example, example 8 in the book. Okay. In a library group of 50 readers, 31 likes science fiction, 20 like detective stories, and 12 dislike both. You have to draw a Venn diagram to represent this information. Let's say that the science fiction likers, we write them as a capital S. So those are the science fiction likers, the ones who like science fiction. And a capital letter D are the detective story likers. Okay. We have to draw a Venn diagram, so we have to first make a box with all possible outcomes, all the number of outcomes in the sample space, and that's actually equal to the 50 readers here. That is the number of outcomes in the sample space. So inside this sample space, we have the science fiction likers. We also have the detective story likers, and we have some people who like both. So here we have the D. Let's say that the amount of people who only like the science fiction, we call that a A, and the ones who like both, we call that a B, the amount of people, and the amount of people who like only the detective story, we call a C. And then we have the 12 people, 12 persons who dislike both of them. So they don't like science fiction, and they don't like detective stories. So they are here. So we have 12 people here. Okay. It is given that 13 readers like science fiction. So that means that the A here and the B must be equal to 31. Because here we have the science fiction likers. And then 20 readers like detective stories. So here we have the detective stories likers. That is B plus C. So B plus C must be equal to 20. And then we have in total 50 people. So we have the science fiction likers, the A, the readers who like both, B, plus the readers who like only the detective stories, C, plus the 12 dislikers, so the 12 here, and that must be equal to 50. So we have three equations here and three unknowns. Now we can get the ABC out of this. So in the first equation we can say that A equal to 31 minus b. In the second equation, we can say that c is equal to 20 minus b. And we can fill in the first one and the second one in the third equation. So if we do that, so the first and the second in the third equation. So we replace this a by 31 minus b, the b stays, and we replace this c by 20 minus b plus 12, and that must be equal to 50. So we have a plus b here, we have a minus b here, they cancel each other. We can move this minus b to the right hand side, and we can move this 50 to the left hand side. So on the left hand side we have 31 plus 20 plus 12, and then the 50 to the left hand side will become a minus 50, and the minus b to the right hand side becomes a b. And then 31 plus 20 plus 12 minus 50 is equal to 13, so b must be equal to 13. And we can fill that in the first or in the second one, that, like in both of them. In the first equation, it gives that a must be equal to 31 minus 13, which is equal to 18. We can also fill that in the second, and that gives c is equal to 20 minus 13, which is equal to 7. So a is equal to 18 and c is equal to 7. And then if we go to part B, we have to find, so if a reader is randomly selected, find the probability that he or she likes science fiction and detective stories. So the reader must like both of them. So both of them is the category B here. So the probability that the reader likes both is equal to the amount of readers who like both, which is the B that we found, 13, divided by the number of outcomes in the sample space, so the total amount of readers, which is 50. And that is the answer. And if we go to the second one, so if a reader is randomly selected, find the probability that he or she likes exactly one of science fiction and detective stories. So the reader can like a science fiction or can like a detective story, but can't like both of them. So that's actually the sum of A and C. So the probability that the reader likes exactly one is actually equal to, so the A plus C, so 18 plus 7 over 50, and that is equal to 25 over 50, which is equal to 1 over 2. And that is the answer.